Hey Java developers, JDK 22 is just around the corner, releasing on March 19th. In this special edition of the Inside Java Newscast, we're going to review the full release notes of JDK 22. This continues a tradition of going through the release notes of JDK releases started with JDK 20. However, I'm going to make some changes to the format this time. We're still going to lead off with the JEPs, the JDK enhancement proposals. Those are the major changes in a JDK release. From there, we'll follow the basic flow of the release notes, new features, remove features, deprecated features, and so on. What has changed is I'm going to consolidate all the performance updates and security changes into their own separate sections. This should hopefully make it easier to find the information you're looking for and maybe keep each section about the same length. In previous release notes episodes, the other notes section went on a bit long. Leave a comment if you like this newer format or if you have any suggestions on how it could be improved. And also don't forget to join us on the JDK 22 launch livestream on March 19th from 1700 to 2130 UTC, where we, the Java DevRel team, will host interviews with key JDK engineers, demonstrate new features, and more. Hope to see you there. Okay, maybe go grab some popcorn and let's review what has changed in the JDK 22. There are 12 JEPs included in JDK 22. For a brief refresher, when a somewhat substantial change is proposed to the JDK, it goes through the JEP process. This is to ensure the change is properly reviewed and the community is given visibility of the change and an opportunity to provide feedback as well. Of these 12 JEPs, 4 are final features, 7 are preview features, and only 1 is an incubator feature. Let's take a closer look at what is in each of these JEPs. As mentioned, there were 4 final features included in JDK 22. They were JEP 423 added support for region pinning for G1. This is a change that is related to JNI, the Java native interface. This addresses issues of threads stalling because they were referenced by objects used by native code. With this change, G1 will keep native objects in the region where they reside while continuing to perform garbage collection. JEP 454 finalizes the Foreign Function and Memory API, or FFM API. The FFM API is part of Project Panama and has a long history stretching all the way back to JDK 14 with JEP 370, then just the Foreign Memory Access API. The FFM API aims to improve the experience, performance, and reliability of working with native libraries, addressing many of the shortcomings with JNI. This JEP includes 5 small changes. Provide a new linker option allowing clients to pass heap segments to downcall methods. Introduce the Enable Native Access Jar file manifest attribute. Enable clients to build C language functions descriptors programmatically. Improve support for variable length arrays in native memory. And add support for arbitrary char sets for native strings. JEP 456 adds unnamed variables and patterns. This JEP seeks to address the somewhat common issue developers experience having to declare variables they do not intend to use. This is not only an issue for velocity, but can cause maintenance issues down the road if a future developer begins to use the previously unused variable, possibly leading to bugs occurring. With JEP 456, a developer can replace unused variables with an underscore. This not only makes code more concise, but also improves the intent of code as well, and as a result, less error prone. JEP 458 launch multi-file source code programs will kill build tools. But more seriously, JEP 458 is an improvement of JEP 330 by allowing the Java launcher to compile and execute multiple source code files. This will not only help those learning Java, but also builds upon Java's emerging story of becoming a scripting language, something you can learn about more from this episode of the Inside Java Newscast. There were 7 preview JEPs included in JDK 22. JEP 447 allows statements to be added before a call to super and constructors. This resolves a long-standing frustration among developers of not being able to validate or perform processing on variables before supplying them to a parent constructor. Be sure to check out this feature and give us feedback on how it might be improved. JEP 457 provides a standard API for class files. It's unlikely most developers will interact with this directly, but it will improve the experience of upgrading between JDK versions. Check out Nikolai's video on this topic. JEP 461 introduces stream gatherers as a preview feature. Stream gatherers are an intermediate operation that can be applied to streams to transform elements within that stream. JEP 463 implicitly declared classes and instant main methods is a second preview of JEP 445 unnamed classes and instance of main methods. This comes with rule changes to implicit declaration of classes in source files and procedures for selecting which main method to call. String templates, structure concurrency, and scope values all enter second preview with JEPs 459, 462, and 464 respectively, all containing either no or only minor API changes. Finally, the only Incubator feature is the Vector API with its 7th iteration of Incubator status. The Vector API will continue to remain in Incubator status pending the release of Project Valhalla features. Let's take a look at the new features included in JDK 22. Support for Unicode 15.1 has been added in JDK 22. Unicode 15.1 adds 627 new characters, bringing the total of supported characters to just shy of 150,000, which is almost as many subscribers as the Java YouTube channel. You can do your part to keep us ahead by subscribing today. Also, as a part of this change to support Unicode 15.1 is improved support for the Chinese National Standard GB 18030. The Java Net Extended Socket options TCP Keep Idle and TCP Keep Interval are supported on Windows platforms starting with Windows 10 version 1709. TCP Keep Count is supported starting from Windows 10 1703. 3 new constants have been added to the Java NIO charset standard charsets UTF-32, UTF-32BE, and UTF-32LE. A new class, list format, has been added which can process lists based on locale-specific Unicode standards. For example, a list of 3, foo, bar, and baz, would be printed out as foo, bar, and baz in US English. Take that, Oxford, deniers. While in French, it would be printed out as foo, bar, baz. Besides the default connotation standard type standard, the class provides 2 additional types R and unit for concatenation suitable for units for that locale. A new method, equal doubles, has been added to Java util random generator, which returns a double stream. The goal of this new method is to overcome some of the constraints related to doubles and next double methods. An optional parameter has been added to the inherit doc tag so that an author can specify the supertype from which to search for an inherited documentation. Additionally, the algorithm for the search for inherited documentation has been modified to better align with the method inheriting and overriding rule languages of the Java language specification. A JDK built-in catalog is introduced to host DDTs, document type definitions defined by the Java platform. The JDK creates a catalog resolver based on the built-in catalog when needed to function as a default external resource resolver. The default behavior of catalog resolver can be configured by the new property JDK XML JDK catalog resolve. Another new property, JDK XML DDT support, was introduced that determines how XML processors handle DDTs. The property can be set on factory APIs as a Java system property or as JAXP configuration file. The new property affects all XML processors uniformly. A few features were removed with this release. The sun, misc, unsafe methods should be initialized, and ensure class initialized methods have been removed. These methods have been deprecated for removal since JDK 15. Java lang invoke method handles lookup ensure initialize was added in Java 15 as a replacement for this behavior. The new core reflection implementation has been the default since JDK 18, and the old implementation is now removed. The JDK reflect use direct method handle false introduced in JEP 416 to enable the old core reflection is now a no-op. Compact profiles became obsolete in Java SE 9 when modules were introduced. The JDEPs profile and P options were deprecated in removal in JDK 21 and now have been removed in JDK 22. customers can use JEPs to find the set of modules required by applications instead. There were also a few features deprecated as well. Definitely consider moving off these features as soon as possible, even if they haven't been yet marked for removal. The sun-mist unsafe methods park, unpark, get load average, load fence, store fence, and full fence have been marked deprecated for removal. Code using these methods should move to Java concurrent lock support park, unpark added in JDK 5, Java Lang Management Operating System MX Bean Get System Load Average added in Java 6, and the appropriate fence method in the Java Lang Invoke var handle added in JDK 9. With every JDK release, there is always going to be a few known issues. One in this section, but two more that are in the performance updates section we will get to later. Strings read with the Java NIO files read string may return incorrect strings when decoding with char sets other than US ASCII, ISO 08859-1, or UTF-8. Reading strings with other multi-byte char sets such as UTF-8 may produce incorrect results. As a workaround, disable compact strings by setting -compact strings on the command line. Next, we will move to resolved issues. These are fixes to known issues from previous JDK releases. In the previous releases, method handles lookup find static var handle eagerly initializes the declaring class of the static field when the var handle is created. This is incorrect, and the declaring class will no longer be eagerly initialized when find static var handle is called. Existing code that relies on this previous behavior may observe a change of the order of the classes being initialized. In previous releases, method handle proxies as interface instanced returned a proxy instance. This has been updated to return instances of a hidden class that can be unloaded when all the instances returned for the same interface become unreachable. Once unloaded, subsequent calls to find a new hidden class which may incur a performance overhead. Names for Gregorian areas returned from the Java Time Format APIs are now correctly retrieved from the CLDR locale data. Previously, these APIs incorrectly used legacy compact locale data. For example, the era names BCE, CE are now returned for the root locale instead of BC80 that are in the compact locale data. For compatibility issues and workarounds, refer to JDK 83200431 for details. Executable element get receiver type and executable type get receiver type now returns a receiver type for methods loaded from bytecode if the type has associated type annotations. Previously, it returned no type for all methods loaded from bytecode, which prevented associated type annotations from being retrieved. Type near now provides access to annotations for types loaded from bytecode. Previously, type annotations were not associated with types loaded from bytecode. Annotation processors can access type annotations for using elements using annotation mirrors, get annotation mirrors, and the annotations will be included in the output of annotation mirror to string. Any programs that relied on annotations being omitted for elements loaded from the class path should be updated to handle type annotations. Prior to JDK 22, Java-C would accept private method references with a type variable receiver. This implies that Java-C compiler would accept a code example like this. Starting with JDK 22, this will be rejected by Java-C. In this section, we will cover other updates, a collection of changes that don't neatly fit into the other categories. In most cases, these changes are covering changes to pre-existing behavior. The Java AWT System Tray API is used for notifications in a desktop taskbar. However, on Linux, the GNOME desktop has not worked properly for several years due to a bug. Therefore, Java AWT System Tray is supported, will return false whenever the JDK determines a platform bug is likely to be present. System Console has been updated to return a console with enhanced editing features. In addition, System Console returns a console object when the standard streams are redirected or connected to a virtual terminal. This is different from the previous release when Java System when system console returned null. If needed, running with JDK console Java base will restore order behavior where the console is only returned when it is connected to a terminal. Additionally, a new method, console is terminal, has been added to test if console is connected to a terminal. On Windows, Java IO file has been changed in this release such that creating a file from the path string with a long path prefix will now strip the prefix. This change fixes several anomalies with file path parsing, helping with interoperability with native code. This change also Java IO file better align with the newer Java NIO file path API. The change may be observable to code that depends upon file to string, returning a string that has a long file path prefix but has no impact to file access. The JDK will continue to use a long file path prefix when accessing files with that prefix. Sun Reflection Factory new constructor for serialization is reimplemented with method handles. This addresses old behavior where in certain situations an ill-formed constructor was returned, creating an unspecified behavior with new instance was called. Now the new implementation will throw an unsupported operation exception to fail fast. The Java.NET proxy selector methods select and connect failure now throw illegal argument exception in all proxy selector implementations when called with invalid parameters. Previously, a null pointer exception was thrown. Locale data has been upgraded to CLDR44. There are two notable date-time format changes included. Mexico and Latin American countries changed their time formats from 24 hours to 12 hours. The full date format for Australia and the United Kingdom no longer has a comma after weekday. The VM command, compile command, will now exit the VM with a non-zero exit after a parsing error occurs. The syntax of the VM arguments compile only and compile command have now been unified. The two on-screen commands now perform the same behavior. In preparation for Project Galahad, the JDK internal VM compiler module was renamed to JDK Graal Compiler. Being a JDK internal module, this should be transparent to most Java users. However, scripts that run JLink to create a runtime image containing the Graal compiler module will need to be updated to use the new module name. Record patterns were introduced in Java 21. However, Java-C allowed final in front of a record pattern, like in the on-screen example. This was incorrect and will now cause a compiler error. Users will need to remove the final keyword. Some foreign function and memory API methods are unsafe as improper usage could crash or corrupt a JVM. As a result, by default, a warning will be issued at runtime when they are used. A new Java-C lint option, xlint restricted, causes warning to be issued at compile time if restricted methods are in source code. These compile time warnings can be suppressed with the suppress warnings restricted annotation. When using the release n flag when n is a version with Java-C, previously the module version descriptor was empty if the version was less than a version of Java-C, i.e. using Java Release 21 when using Java-C from JDK 22. This has been fixed. If you're using a pre-release JDK, the additional decorator flags such as EA for early access will also be included. There were several changes to the show settings option. Show settings and show settings all now differ in behavior, with only summary information being shown for both locale information and security information, displayed with show settings. To view all the information related to locale and security settings, either use show settings all, which as the name suggests shows all settings information included for locale and security, or use show settings locale, or use show settings security for detailed locale and security information respectively. Security details can be further divided by subcategories, all properties, providers, and TLS, which can be written as show settings and then properties are the other examples.
All of that JDK 22 stuff sounds really interesting. If you're looking for something more action-packed or interactive, why don't you join us on Tuesday at 1700 UTC, that's 5 p.m. UTC, here on the Java YouTube channel for a live stream, a JDK 22 release live stream where we go over all these features. We're going to talk to some experts like John Rose and Ron Pressler. We'll have a section on the community. It would be great to have you there. So you can already get notified right now. And that's it. Back to you, Billy.
In this section, I'll cover all the performance and performance adjacent changes in JDK 22. I would also highly recommend checking out Thomas Schatzel's article he published on GC changes in JDK 22, which will go into more depth on many of these changes than I can here, as well as link to a more extensive list of all the GC changes in JDK 22, link in the description. G1 will now reclaim regions that failed evacuation in the next garbage collection. Previously, these regions would be moved to the old generation on the assumption that they were completely full. However, often these regions were simply sparsely populated, making them candidates for reclamation. This change should reduce heap pressure and the need for GC activity. How parallel GC partitions scanning the old regions has been significantly reworked. How parallel GC used to handle scanning was inefficient, particularly when working with large object arrays. This change now makes parallel GC on par with G1 GC when working with large object arrays, reducing pause times by as much as a factor of 5 in some use cases. The X no agent, X debug, and debug options have all been deprecated for removal. All these options have been ignored for several years now. With this change, a warning message will now appear saying the option is scheduled for removal. Parallel GC will now have better throughput with large object arrays. This was a result of a change in its internal bookkeeping to use data structures like with serial and G1 GCs using. This can result into up to a 20% reduction in GC pause times when using large object arrays. Serial GC will now have better throughput with scarce dirty cards. This is a result of a change to how serial GC will locate objects when finding dirty cards. This can result into up to a 40% reduction in GC pause times when using large object arrays. G1 will now distribute work during the code root scan phase across multiple threads. Previously, this work was performed by a single thread, creating a scalability bottleneck. G1 will now expand the heap less aggressively during the remark phase, as it will now consider eaten regions empty instead of full. Running the JVM with use GDC and non-default value of object alignment in bytes may lead to JVM crashes or incorrect execution. A noticeable increase in startup time will be observed when using Start Flight Recording option with smaller applications. This is due to an ongoing initiative to reduce technical debt in the JFR bytecode instrumentation. This work is anticipated to be finished in a future release, resulting in startup time that is comparable to JDK 21. It's now possible to enable JIT compilation when creating a CDS archive. When using share dump to create a CDS archive, it can also be included with the argument mixed. It's recommended to only use this when creating an archive with a very large class list and when deterministic content is not required. Hotspot HS error files will now print the locked stack. It only gets printed when new lightweight locking mode is enabled, locking mode equals 2. On screen is an example of what will be printed to HS error. A new flag, user thread wait attempts at exit, number of waits, has been introduced. This flag specifies the number of waits the JVM waits for user threads to stop executing native code during a JVM exit. Each wait lasts 10 milliseconds and the maximum number of waits is 1000 and the default is 30, which is the same as existing behavior. The Linux specific options use SHM and use huge TLBFS are now obsolete. Use SHM offered no advantage over use huge TLBFS. Use huge TLBFS is now considered the default setting in scenarios where it could be used. On Linux, if the JVM is started up with use transparent huge pages, but the system does not support transparent huge pages, the following warning will be printed to standard out. Use transparent huge pages disabled. Transparent huge pages are not supported by the operating system. NMT reports will now show peak values for all categories. Peak values containing the highest value for the committed memory in a given NMTM category over the lifetime of the JVM process, like in this example. Heap dumps will now be segmented into two phases. Previously, a VM was paused the entire time during a heap dump, but with this change, the heap dump is segmented into two phases. Phase 1, the application is paused while concurrent threads write data to segmented heap files. During the second phase, the application is resumed while the heap files are merged into a single complete dump file. The amount of time it takes for a heap dump to be performed is unchanged, but the length of the pause time is reduced. Now we get to the security updates in JDK 22. The jar signer and key tools have been updated to support the hierarchical signature system, Leighton-Macaulay signature, HSS LMS signatures algorithms. Sorry if I mispronounced those names. The XML signature implementation has been updated to Centuriario 3.03 and added support for 4 new SSH-A3, RSFA, MGF1, and signature method algorithms. The JDK Crypto EC module is being deprecated with the intent to remove it. An empty module exists as a transition for developers to fix applications or JLink commands with hard-coded dependencies for removal. The Sun EC JCE provider with the provider elliptic curve cryptography is now in the Java-based module. There should be no differences in cryptographic functionality with this deprecation. When instantiating a third-party security provider's implementation of a KEM algorithm, the framework will now determine the provider's codebase and verify its signature. This ensures that only providers signed by a trusted entity can be plugged into the JCA, which is consistent with the other JCE service classes. 2 new system properties, JDK TLS server max inbound certificate chain length and JDK TLS client max inbound certificate chain length, have been added to set the maximum allowed length of a certificate chain accepted from a client or server during TLS DTLS handshaking. JDK 10 added support for the include dir name directive in KBR5 conf. With this code change, files in the directory are read in alphanumeric order. Prior to this change, the files were read in no specific order. As with every JDK release, many new certificates have been added, but it doesn't make sense for me to mention them here. Be sure to check out the release notes, link in the description for all new certificates. While we try to minimize the differences between Oracle Open JDK and Oracle JDK, there are a few small differences, including Oracle JDK offers installers, which not only place the JDK binaries in your system, but also contain update rules, in some cases handle some common configurations. Open JDK is only offered as a compressed archive. Usage logging is only available in Oracle JDK. Oracle JDK requires that third-party cryptographic providers be signed with a Java Cryptographic Extension, JCE, code signing certificate. OpenJDK continues allowing the use of unsigned third-party crypto providers. The output of version is different. Oracle JDK offers Java and includes the Oracle-specific identifier. OpenJDK returns OpenJDK and does not include the Oracle-specific identifier. Oracle JDK and later are released under the Oracle No-Fee Terms and Conditions license. OpenJDK is released under GPL v2 WCP. Oracle JDK distributes FreeType under the FreeType license, and OpenJDK releases under the JPL v2. The contents under the legal directory are therefore different. Oracle JDK has the cup and steam icons, and OpenJDK has Duke icons. Oracle JDK source code includes the Oracle proprietary confidential use is subject to license terms. Source code distributed with OpenJDK refers to the GPL v2 license terms instead. Well, that's it for this episode of the Inside Java Newscast. JDK is another exciting release filled with new features, performance improvements, and security updates. I'd give it 5 stars, but maybe I'm a bit biased. If you're interested in learning more about JDK 22, be sure to watch our live stream next Tuesday, link in the description. If you enjoyed this video, leave a like and share it with a friend. If you didn't like this video, still like it but share it with an enemy. If you suffered, why not them? Also, don't forget to like, subscribe, and leave a comment, maybe with a change you're most looking forward to that's in JDK 22. Until next time, happy coding!